Thanks to all of you for coming. This is one of my favorite events of the year, and you all make it a wonderful experience for us. I'm going to say a little bit about the Memory and Aging Center and UCSF and what new has happened in the last year since you visited us. Can you hear me okay in the back? Pull closer to me. Okay, great. There. Okay. So this is the Memory and Aging Center. We have about 180 employees now. We started with just me, so I think that's an improvement in a lot of ways. So we have about 27 faculty. I think we're almost like a family. We really like each other, and we really love our patients and people we get to work with. So I think we all feel very lucky to be here in San Francisco on this incredible new campus. What do we do? And, you know, I think at any given moment I'm doing all three almost at the same time. We see patients and offer care. Often while we're doing that, there are trainees that are learning how to do this properly. So we appreciate that all of you work with our trainees. I think this will make a difference in the world as they move out of our program and, you know, begin to take care of people themselves. So that's our education. And I think my research has always come from the individual patient at the bedside. I think about what they tell me, whether they're a healthy control or whether they suffer from frontotemporal dementia. And so I think that every time we are engaging, I think it is helping to advance the research initiative. I almost didn't put this slide up, but I had to do it and then forget that I'm bragging. So anyways, I think we don't have an undergraduate campus here, and we don't have a great name either. I mean, UCSF, it doesn't ring any bells for people. But I just wanted you to know that we're a public institution. And I think an extraordinary one, and I think if one measure of this is research, this is the #1 school of medicine, school of pharmacy, school of dentistry, and school of nursing. So I think this is a place that brings extraordinary trainees and also brings lots of funding to the San Francisco Bay Area. In fact, I think that this place is the #1 public institution for funding in all of these different areas, and only institution that gets a little more, and we're rising quickly, is Johns Hopkins. Also, we live in an incredible neurology environment, and our department has been #1 in the country for 5 years in NIH funding. So although we're a public institution, only 3% of the funding comes from the state. Some of you may not know that. So most of the funding comes from the, the initiative of the faculty and trainees at getting extra funding, whether it's philanthropy or from National Institutes of Health. We have broad participants. I think we're unusually broad in terms of the type of people that come into our program. We're a National Alzheimer's Disease Research Center. We were ranked #1 last year in NIH reviews. We have a major effort around the frontotemporal dementias and related disorders. We have a healthy aging program, and I have to say I'm really proud today that my neighbor, Jane Morrison, and her neighbor and my friend Josie Caritas are here. And Jane is almost 95, and she's a real force in the city of San Francisco and has actually protected our center periodically when funding cuts were being considered. So anyways, not only is she a healthy research participant, but she's a fierce defender of all that is good in the world. So anyways, thanks, Jane. So I think we believe about a lot in sharing and collaboration. So whenever you participate in one of our studies, you're de-identified. Nobody will ever know your name or anything like that. But the samples that you give us, the data that you give us, is going to be available to people across the world. So Anna Caritas, Josie's daughter, works with our biosamples. And I would say every week we are getting requests from across the world to think about cells that you have given to us, to think about risks for Alzheimer's disease, genes that protect against Alzheimer's disease. Some of you have given us skin cells that we've converted into neurons, and these are highly sought after. This is one of the few places that does that. So we get constant requests, and Anna, a lot of her life is just dealing with these requests, making sure they're legitimate, and getting the kind of samples that we collect across the world. This is what Joel Kramer wanted me to talk a little bit about today, and I think increasingly we are moving into the focus of normal aging. I'm in that category, I think, although my staff wonders sometimes about that. But I think the idea is that the goal of our effort is to delay or prevent cognitive decline as we age. And I think one of the things we've learned from our Hillbloom Healthy Aging program, supported by Steve and Zoe Schwartz, is the fact that many people who age in a glorious way. Their brains not only don't decay with memory disorders, but they actually get more altruistic, more socially minded. And I think this is something that our program really focuses around. Why do some people age in such a wonderful way? And I think increasingly we're thinking about those of you who might be at risk for developing a degenerative disease with new imaging techniques that we have. So I urge all of you, you look pretty darn healthy to me, if you haven't already, to come participate in our Healthy Aging program. And how young can you be to be healthy ager?
Well, 50 and up.
50 and up, okay, okay. Almost, how are you? Okay, okay. So one of the things that we have really benefited from are these, I think, groundbreaking consortia. These are funded by philanthropy, and they're funded by families who have genes that cause different types of degenerative disease. And we have two of these that are international in scope, one the Consortium for Frontotemporal Dementia, and the other the Tao Consortium. And in these, we've been asked by the philanthropists to bring the best people in the world together to solve a problem. With the CFR, we've said we will cure one type of frontotemporal dementia by 2018. And boy, is that ever compelling to see the funders together with us, the best scientists in the world who ordinarily would be isolated in their laboratories, who are interacting with people like Suzee Lee and Bob Levenson, thinking about how to better diagnose and decide whether a therapy is working. Just one quick example. This is the Tao Consortium, and includes one of my heroes, Stan Prusner, and the Tau Consortium focuses on developing drugs for tau. We already have antibodies that we're testing in people. Adam Boxer, I think, runs one of the premier programs in the world around this. So I think we're beginning to see from our research already clinical trials that the first time show great hope. This is skin cells converted into nerve cells in one of our patients. And what we can see here is this is a gene that this individual carries, AT. Most of us are AA. And we've learned that in this gentleman who developed tauopathy, a disease of tau, that his neurons spontaneously in cell culture develop a tauopathy. If we treat it and turn him into an A, the cells recover. So I think this is one of the really new UCSF technologies that we are using to study genetic susceptibility. Howie and Adam Boxer have gotten 2 major national initiatives, actually international, that are allowing us to study huge numbers of people with frontotemporal dementia. The first time in the world that this has ever been possible. This is a huge new advance for our program. A word about the imaging, because there isn't much about it today. So this is Gil Rabinowicz's program, and we saw for the first time yesterday a positive study in Alzheimer's disease. We haven't seen this in about a decade. And the idea is that we can now image the bad Alzheimer protein you can see here in red. That's the amyloid protein. And in previous studies, before the one that was reported yesterday, if you were in an Alzheimer trial, we didn't really know whether you had the Alzheimer protein or not. The reason this trial was the first successful one was because they were able to image amyloid in the brain of people before they were put into the trial. So at least we were treating people with an anti-amyloid therapy who really could benefit from the therapy. So that was one of the reasons that this study was successful, and I think our program here has played a major role in this diagnosis. Yeah, so I think the people who got an antibody against the amyloid did better. They did not progress as quickly as people who did not. So this is really exciting. This is not just a symptomatic therapy, this is a disease-modifying therapy, and you're going to hear a lot more of these in the next decade. Do you want me to stop now here? Okay. Give me 5 minutes, Lisa. Okay. So the other area that has really been pioneered by Gil Rabinowicz here is Tau imaging. So I'm a Taoist. Some people are amyloidists or beta amyloidists. They're Baptists. But I believe Tau is like the key to this religious battle. And we can now image Tau. And if you have Tau in the brain, it correlates with your symptoms. Amyloid can be there and you can be asymptomatic. But this Tau protein is really critical to the type of symptoms that people are going to develop. And so we are just beginning, Adam will talk about this, to image people to see whether they have this bad Tau protein in the brain and thinking about how to get rid of it. So I think this whole area of molecular imaging, pioneered to some extent by Gil Rabinowicz and Bill Jagust here, is really the next step to deciding whether or not therapies are effective and who should be treated. Here's a latest advance that's come out of Howie Rosen's program, and this is quantitative imaging. So what we can do now, and this was one of my patients, is take an image and say, statistically, what is different about that brain to healthy controls who are matched? And in this gentleman, we see atrophy in the temporal lobes on the right. This is a form of frontotemporal dementia. And I think this is just going to be a huge tool for radiologists who just visually look at scans and don't usually comment on the atrophy. But I think this ability to quantitatively measure what your brain looks like in a statistical space is just an incredibly important way for us to improve our diagnostic abilities. Okay, you're going to hear from Kate Possin about care ecosystem, but I hope many of you will participate in this. This is a really exciting effort to improve care for people who are afflicted by these diseases. Last comment is education, and this is Nelson Mandela. Education is the most powerful weapon which we can use to change the world. And I think that's why we're at a university here, a medical school, and I think that we are very proud of the training. And I think you see it reflected immediately in our research coordinators who I think come in extraordinary, but quickly learn by working with people afflicted by these diseases and by healthy aging, how to take care of people. And I think this is something that we really focus on in our program. We have a number of trainees who've gotten awards. This is just some of the few that have gotten in the last year very difficult awards. These are K awards from the NIH, American Academy of Neurology, Eliseos Karageorgiou also has one. But I think these awards allow these people to grow and eventually become leaders in the field. And last slide, this is our worldwide reach through training and collaboration. We have about 70 individuals from foreign countries who work with us and bring the training back into their countries, into their communities. So again, we appreciate that you work with our trainees. It's an important part of our mission. And sorry for going over.